in this specific example, I'm going to be pulling data out of our SQL database and that OPC UA server, and I'm going to be exposing that to a web browser. So this was exactly one of those scenarios I referred to earlier. You obviously don't want to expose your SQL database to the internet or your UA server to the internet. This gives a way to tunnel that data out one directionally, a data diode, if you will, to expose that data in a secure way. You may not still want to expose your production data to the internet, but this would be a way that could be done. So let's add a new connection here. This is going to be our API get test. And right here, it's the same deal as before. We need to add our objects. And so we're going to be pulling data from a UA server. We're going to be pulling data from a database. And we're going to be pushing data out via a REST API. So the UA server and the database we've already set up the plugins for. We're just going to reuse the same ones we've configured. But when we set up our REST plugin, we only set up a REST connection. So we set up the client piece. We need to set up a REST API. So the setup there is separate. It's a little different. So let's create a new API here. Call this the demo API. We need to specify port. Port 80 is usually in use, so I'm going to use something slightly different. Try 8585, and then we can expose, or we can add an optional route prefix. So what that route prefix is, if we look at the bottom example URL here, it's just something that gets added after the port before the actual endpoint that we're going to be configuring later. We'll just add your demo router API, just for giggles. And then for our authentication, we do support authentication here, and I'm going to set up some basic authentication so that not everybody can get at this data. I'm just going to set up the user and have a very secure password here. We do support HTTPS. And again, if you have a client that wants to use this OpenAPI standard, we can expose that data via OpenAPI. In this case, I'm going to keep it enabled, but that's not going to be the case here for a browser. That's all we have to configure here. If I hit OK and jump back to my connection, we can now set up that API. Here's a goes. We actually need to come to a trigger. So there is a REST trigger here at the bottom, and if we set that up here, we see our list of APIs. So the reason we would want to use a REST trigger here as opposed to a REST transfer object is because when a REST client hits this API that the OPC router exposes, we want that to trigger some sort of data flow here. So whereas with the REST client example, the data flow is being triggered by an OPC tag changing value. In this case, we want this flow only to trigger when a REST client sends a request. So we're going to use a REST trigger. Here's our demo API. And we can define an endpoint for those clients to connect to us with. And what I'll do here, let's say, we can just get user data. We can make this whatever we want, but we do need to specify an endpoint for a client to hit. We can select what HTTP methods we want to be able to trigger this flow. And in this case, I want the data flow to be one directional from SQL and UA out to the OPC router. So I'm just going to select the get method. We're not going to select any of these other HTTP methods. And what I want is my client needs to specify what data does it want to get. So if I pull up SSMS again, I have a sample table built here for products. You can see I have some sample products built. So basically, based on the product ID, I have some set points recorded. So what I want is I want my REST client to pass in this product ID, and I want the OPC router to then go and retrieve the corresponding set points and pass those out through the API. Go back to our router. So in order to do that, obviously I need the client to pass in the product ID. So I'll specify field here, and I want that to be passed in as a query string. This is a little bit easier. And that's all we got to do. So here we have our API exposed now. You can see the full destination is going to be demo router API, which is what we specified in the plugin. And then user data.json is the endpoint that we specified here in our trigger. So we're going to be pulling some data out of these different data sources now. So for our database, it's the same deal that we had before. We want to connect that to our local SQL demo SQL server. And we're going to do a select. We're pulling data out. And just as before, I have my product table, and we have the columns that we're interested in. So interested in those 3 set points. In this case, the filter, we can filter this a little bit because we want this database, the select statement, only to return data for the product ID that was specified. So we're going to add a filter here, and we're going to select the product ID, and we want that to be equal to some value. And that value here, you can see in the preview, that value is going to be dynamic, what we want that product ID to be equal to. And just for the sake of this, I'm going to come to the query tab. And if the select statement goes empty, I don't want it to throw an error. Basically, if a client requests a product ID that doesn't exist, I don't want this to just throw an error. I want to just return an empty record. I don't need it to stop working. I'm just going to tell the client, the browser, hey, this product ID doesn't exist. So you can see we can limit our requests, but because we know what that SQL table will look like, we really only I want to make sure that these empty selects are handled properly. So there we have our 3 set points. We can see our filter. We can pass in a product ID. And we know that product ID is going to come in from our client, so we can go ahead and set that up already. So from our OPC UA server, also set that up here back to our demo UA server. We'll browse some tags, and we are going to, let's pull in some good parts and bad parts. So in this case, maybe the REST client wants to get a feel for, at these set points, how many good parts and bad parts are we producing. So this is going to read the current good and bad parts from this UA server. Now, the response that this client is expecting is a JSON payload. So obviously, I have all these separate pieces of data, so we need to combine that for a well-formed JSON payload. So there is our JSON write object. So in this case, we have our separate pieces, so we need to use a write. And similar to the JSON read, I find the easiest way to set this up is to just come here and we can just construct our JSON payload shorthand. So I'm going to give a product ID that's going to be passed back. I'm just going to put a placeholder. Then we have our 3 set points. 1. I know that to be an integer, so I'm just going to put a placeholder there for now. 2, and I'll show you why I'm doing this here in just a second. 3, just basically constructing what a payload could look like, and then we have good parts and bad parts. Okay, bad parts. All right, so just as with the JSON read we saw earlier, if I now come to edit, I see all these data points already available for me, so it's as easy as me hitting this little add expression field for me to be able to do something with those. I hit OK now. There we have it. So good parts goes to good parts, bad parts, bad parts. 3 set points need to get thrown in here, and then the product ID is actually coming right from a request, so we're just going to echo that back. And the output of this JSON write document is this JSON document. We're going to put that in the response body. So that should work. So if I go ahead and set this productive, and again, because we added a new plugin, then we need to restart the service here. Awesome. We'll come to our state monitor. And in this case, the trigger is us doing something. So there's no regular scheduled execution of this data flow. So if I come over here to my browser, and let's go ahead and set this up. And I think we used 8585 for demo router API, user data.json. Demo router API / data.json. And we need a product ID. So let's add a quarter parameter here. ID, type it out. Product ID, yep. And now let's go to SQL here, and I'm just going to copy one of these out. Let's paste that into a browser. So obviously we need to specify where that API is running. This is going to be the little prefix that we configured in our plugin. The endpoint we want to hit that was configured in our data flow. And then the query parameter, the query string that we're going to be getting data back for. So if we execute this, as expected, we need to authenticate. We set up the API to require authentication. You can see here's our data. So it matches. It looks exactly like what our JSON payload was that we set up, our dummy payload. And if I compare this to the data in SSMS, you can see for this first one, those values match. There's good parts, bad parts are just random values being generated right now, so they're nonsensical. But if we were to change this now to something, this last one here, you can see that the response payload will change based on what product ID we pass in. And if we pass in a dummy request, we get back nulls. So this is where that empty payload, I didn't want it to return an error. I just want to say that, hey, this product ID, the set points are null. Obviously, how you want to set this up is going to depend on where you want that error handling to happen. So this alone is already an example of how to get the data out. But the scenario that we described and talked about earlier was all around security. So we don't want to expose our UA server and our database to REST clients directly. We want the router to act as a data diode between those. And in that sense, I'm not satisfied quite yet with what we've set up here. So let's add another database object here. And I want to log what requests are coming into this endpoint. I want to know who's asking for what data. And in that sense, we have this demo SQL server again. And I want to log all these requests. So we do insert, and I have an audit table already built here. We can see what fields that I have here. So I'm going to log what the request is. I'm going to record what the method is that's being requested. I'm going to record the source IP. Where's that request coming from? I'm going to record what record are they asking for? What's that product ID? And the request timestamp, I could pass it in, but in this case, just as with the other table, I'm actually going to let SQL provide that timestamp. And the ID is just identity code, so I don't have to provide that data. And so as you expect, these are all already available in our data flow here. So the product ID, that's going to be our record ID that's getting requested. The request body, pass into the request, or method, pass into the method. The client IP, we can pass into our source IP value here. Let's deploy that and see what we see. In our staging here, we can see as expected, most of this flow isn't being changed. We're just adding a new object. So we continue to publish this. Give it a few moments again to initialize here. And then if I go to a browser, Control Z does work. That's nice. So we can execute that here, execute it again, and see the values for what we would expect. ID. I have a limit on this. So there's our dummy field, and if I come to our SQL Server now, we haven't modified this product table any, but if we come into our audit table now, we can see those requests all get logged. So that error we saw a second ago, this record ID field, I have set pretty small because I don't want my SQL table to grow indefinitely. In reality, we would probably need to expand that a little bit to capture edge cases like that. But we can see that the method that we're doing is a get. We can see it's coming from my local source IP. We can see the record ID that's being requested. So this request column is blank, and that's because there is no body to my request. If my browser were passing in a JSON payload and I was doing something with that in the OPC router, we would see that payload getting logged here in the request column. But because the browser is just doing a GET request on that API endpoint, this request column is expected to be blank currently. And I'll show you an example in a second where that's not going to be the case. But now we have some auditability. We can see who's requesting what data. We know the user that they're authenticating with because I set that up in the plugin. I could log that here, but it's also unnecessary the way that I have it set up currently. So from here, that takes care of that second example. So if I pull that back up here, we've now done exactly this. We can, from our browser, we can request data from the router, and the router is retrieving that data dynamically from OPC UA and from a SQL database. And in this case, we've actually added a third item here to add some accountability to log what requests are being processed through the router. So with that brings us actually to our third scenario. So now I'm not satisfied anymore just getting data out of the OPC router and out of these data sources. I want to be able to add a new product to that product table. So if you're not familiar with Postman, that's going to be the REST client, the client I'm using today. I think it's we'll go as far as to say it's probably the de facto test client when you're working with APIs. But if you have any cool tools that you use to test this stuff, let me know. I'm always in the market for cool new test utilities. But we're basically going to just flip this around. We're going to use that same API plugin that we've already configured. We're going to have a JSON payload that Postman is sending to the OPC router. And then we're going to log that data in SQL and push it down to the PLC. So jumping right back to the router. So we have our state. So I'm going to add a new connection. And to do this, because why not? I'm actually just going to copy the existing one. I'm going to paste that right in. Because the data flow that we're working with here is going to be too different. And why go through all that setup work again for the API when I already have one set up, right? So we're going to be accepting posts. Set that up here. And so we're going to edit this. So in this case, we actually don't need JSON write. We're probably not going to be pushing the good parts and bad parts to the PLC, so I'm going to delete this one. But we do want to insert some data to our database, so I'll keep this object here. I'll delete this error here. And our audit table is going to stay unchanged. We just still want to log all the data. Now, the only thing that really needs to change is I need to come in here and I need to change the method that we're accepting on this trigger to be a post. In this case, we don't need to pass in a product ID here because we're posting a JSON, or a REST client is posting a payload to our endpoint. We'll delete that. So basically, this is now, we're getting in a JSON payload on this request body, and we're going to need to do something with that payload in this empty space here to be able to insert that to our SQL database. So before we get to that, let's switch our database around here to be an insert rather than a select. And we do want to now provide that product ID as well, because the goal here is to add new products to our product table. So have that set up here. Now, just as with the REST client setup, where we're going to be receiving a JSON payload from our API, so from that REST client out there, and we are going to be processing that with a JSON read request to pull out some individual data items. So from here, I'm going to go right back to that edit window, and I could type out what the format is, but in most situations, you'll know what that payload format is ahead of time. So I actually have a sample payload sitting here on the side. So we're going to be expecting that client to pass in a product ID and then those 3 set points. Again, the values here are just placeholders. We hit edit, and just as before, we can see these, and now we can select which fields we want to work with. Hit OK. Now we have this set up. The request body is now going to be passed to our JSON document, and out comes a product ID set point. Set point 3. And in this case, we do want in our database, we also need to pass this product ID down to our record ID because we want to log what product ID is being added. And that's actually all we need. So if I now set this productive, we'll be in good shape. Let's create this new template. It's a new flow so everything's green. And in this case, we didn't modify any plugins. So you can see it didn't ask me to restart the service, and that deployment was a lot faster than what we've been seeing. So our other data flow, this API get demo, is still running. So if I were to pull up a browser, I can still hit that same endpoint and pull in an API so that we're still getting the data flow out of the SQL Server. But if I pull up Postman now, I also want to add a new command here. And if you're not familiar with Postman, it's a useful little utility. 168.2, we just want to specify that same exact endpoint that we used in the browser. As a matter of fact, I am going to do as far as just copy and paste that out. In this case, there's no query string because we removed that piece, but we do need to specify that there's some basic authentication, user, very secure 1234 password. Don't do this. But we now also need to specify what the body is that we want to pass in here. If you recall, we specified that endpoint in our router, and if I come back to that connection here, I'm actually going to go and grab that. Paste that in here. Raw data, formatted. And now we can change what product is. So let's add a product 5. Add all the 0 set points. Why not? So if I post this now, and actually I need to change this to be post. Hit send. You see, we didn't get any sort of response back, so no error response, which is good. We didn't configure the OPC router to send back a thumbs up if everything worked, so we didn't get one. But we would expect to see an error if this failed. So if I come in here and look at our state, we can see our product ID and all zeros were sent to SQL. We can see the JSON payload, our post, our IP address, and that product ID was sent to our audit table. So if I pull up SSS again, and let's refresh our audit table. So there we can see now, because there is a JSON object being posted to our API, that request is no longer empty, and it's a post. We can now also see that that's been added to our audit table. And if I refresh our product table itself, we can see that that product ID 0 with its set points has been added here. So these were all kind of separate pieces. We can't do all of this together. So if, for example, in this connection, when somebody requests data, we wanted to include weather data in that response, we can also add a REST client here to pull that weather data in and return it through the OPC router. Where now your REST client has one endpoint that they hit, and they're getting data from all of these separate data sources, being none the wiser where that data is actually coming from. Now, typically when I do trainings like this, or I sit through trainings like this, I would say when all the data flows are super simple. So I have gone ahead and I've put together something a little more extensive to show you, and I'm going to go and set this up, but what this stuff can look like. And to show you that all the pieces that we just saw in these 3 scenarios, when put together with some of these other transfer objects, you can get some really complex data flows here. So if I zoom in here a little bit and we can see what's happening. So we're reading some location data from our OPC server, some good parts, bad parts, and line speed. We're also receiving some weather data, so we're hitting that same weather API. And the app ID, so the key, and the city ID is all being read dynamically from a PLC out in the field. So we can change what city we're reading the weather for relatively easily. Just as with our first scenario, we're then parsing that JSON read. I've written a little script here to convert our pressure from millibars. I'm not sure if we use millibars to PSI, which is a little bit more useful. And we've done that for 3 cities. So the other data flows here are all relatively similar. And we're having our router generate a GUID just to make sure that we can treat these payloads uniquely. We're including the system time as an ETC string. And then we're sticking that all back together into a big JSON payload for something like blob storage or however you wanted to process that. Or we can expose this out to the REST API like we just saw in scenario 3. So with that, I think I know I went through those relatively quick, but that's all I had. And with that, I hope there's some questions, and I'll open that up for questions.
Thanks, Mark. A lot of great content there, and exciting stuff. We do have one. Can OPC router be installed on a virtual machine? Are there any special considerations for installing on a virtual machine?
None at all.
That's from Suresh Nair.
Nope, none at all. This happened to be running on my laptop here locally. Most of my other test installations of the OPC router are all on virtual machines. There's no considerations or concerns at all. There are 2 separate installers for OPC router. One is for Windows 10 and Server 2016 and newer operating systems, and one is for Windows 7 and older. But that's going to be true whether it's on a virtual or not. So there are no considerations for it running on a virtual at all.
Okay. I had one, Mark. If we could go back over to Postman and bring your Postman back up.
Yes.
So, when you were talking about the response you get back or don't get back based on what you configure, yep. Let's also point out, though, that you did get an HTTP 200 OK.
Yeah, true.
Which does give you some indication that the endpoint received it and got it back. Is that right?
Yeah, absolutely. Yeah. So we did get back a 200 OK, so the API responded with the HTTP response that everything was happy. We didn't get a payload or anything back that says happy or sad. We did get a 200 OK, though. So this was not we fire a payload out and the router we assumed that everything worked. We did get back that HTTP 200 confirmation that everything worked. We just didn't get back a payload or anything that confirmed what was changed. Which, if I actually pull that up here, that response body, if I were to pass in a string here, and just for why not, let's do that. So I'm going to pass back a constant, which if I pass back a constant body and we push this to the runtime service, I do that same post again, and I'm just going to change this ID slightly. We see now we get back that payload that we're passing back. In reality, we probably want to make this dynamic based on whether it succeeded or not. We can send back good or bad. But yeah, when I referred to there wasn't a response, I was just referring to the payload. John, absolutely right that we do still get back HTTP 200 OK. So we did get back a confirmation that the request was received.
Okay, great. Thanks, Mark. So some multiple other questions here. I'm going to kind of take folks who I see all of these. I'm not necessarily going to go in order. This is relevant. Can the router be set up in a high availability group, or what options are there for redundancy?
Yeah, absolutely. So high availability always means something different depending on who you're talking to. But with the OPC router, if we can do here, settings, we can not only configure OPC router redundancy, where you have two separate OPC router instances and separate VMs, where really the only requirement is that there's a network connection possible so that they can talk with one another. And this OPC router redundancy allows us to have a primary OPC router that's doing all the talking. The secondary OPC router is really just pinging the primary to see, hey, are you online? And if it goes offline, it then spins up and starts talking until it realizes, hey, the primary is back online, and then it shuts itself back off. So it recovers automatically and switches back to the primary automatically. And if we were to set this up as that secondary instance, really how quickly that failover happens is a function of how often we're checking. So if you're checking every second, well, you're going to see a quicker failover, but this is going to generate a little extra network traffic. So we can set up redundant routers. And then within the plugins themselves, I'll pull up this plugin again. There are redundancy settings here where we can set up redundancy within the plugins themselves. And that creates this really nice, almost Christmas tree hierarchy where not only are the plugins getting data from redundant data sources, but we have redundancy within the router itself that if one router fails, the other one can spin up and talk to the same data sources.
Okay.
Which if that doesn't answer your question, let us know. We can talk to you offline with more specifically what you mean with high availability.
Well, Mark, I can give you a little more insight. They were asking, they did reply, thanks, but would being in a Microsoft cluster failover group change any of this necessarily?
No. Nothing that I've said would change that. If you're running this, I'll add on that if you're running this, in VMware or vSphere, and you have those set up in high availability where VMs can travel, that doesn't change it any. That's a different way of handling that high availability where you don't necessarily need the redundant router instance, but it's not a one or the other. You can have them both working, but running this in a cluster wouldn't change any of that. It may change some of the licensing answers, but it wouldn't change the functionality.